Thanks, Annie. Okay, so let's start. I just started recording the audio and video, so we are now, yeah, we are now getting started. Okay. Thanks again for everyone joining today's webinar. So today's speaker is Annie Gosh. So Annie used to be at University of California, Davis campus, and Annie has been also working with many of CGIAR Center colleagues on the use of remote sensing data and R-based spatial analysis and many other things. But now Annie is joining CGIAR as an agricultural risk data scientist at CIAT, a biodiversity CIAT Alliance based in Nairobi. And yeah, this week we have 3-day conference in Amsterdam for the geospatial community of practice in CGIAR. And during the meeting, we asked Annie to also share one of the presentation and also kind of training workshop, giving training workshop on agricultural monitoring with planet data. And yeah, I will give floor to Annie to walk us through how he has been using planet data and see how we can also take advantage of that. Okay, thank you, Annie. Please go for it.
Yeah, so thanks for the introduction. So what I will do today is I will share some of the experiences we had working with planet data, primarily for crop time mapping, and we were hoping to use that for some agriculture insurance products. And this was done as a part of a work we had with the Future Innovation Lab on market access and resilience based at UC Davis. There is a couple of students and also researchers working on this project. I will acknowledge them later. So yeah, just to confirm, can you hear me well? Just got a notification that okay, that's probably okay. So what we will do is what I'll do is I'll have this I'll have a set of slides, and at the same time I'll jump to different other interfaces. Primarily we'll need a web browser, and I'll also ask if you don't have a QGIS installed, then maybe you can just quickly install the QGIS. I didn't request it before because most of the time I find that it is already like you are already using it. So that's the plan for today. So for participants who has, like for us who has not used planet data before or have not heard about planet, I just wanted to give a brief background of it. So it's a private company owned by started by some NASA scientists, and they wanted to provide some inexpensive alternatives for satellites that we generally know about. Like, for example, Digital Globe has this Worldview series. From NASA, we have Landsat. From ESA, we have Sentinel. So similarly, they wanted to develop something like a series of satellites that will be used for Earth surface monitoring, but the architecture was very different. So here their philosophy was to develop a lot more of the satellites, but with a lower built-up cost, and they are of very small size. So we are talking about satellites of the size of a shoebox. So it's like few kilograms, and size is 10 by 10 by 30 centimeter. And they have been launching it like hundreds in the sky at a time. So, and the idea is each satellite will have their small footprints, and then when you combine this 150 satellites, then we are talking about like 150 multiplied by these all small footprints, and they're covering the Earth almost every time nowadays. So what I know is there are around 150 active small satellites operated by Planet right now. And apart from that, Planet also down the line, Planet also bought Rapid-Eye constellation and SkySat constellation. Rapid-Eye would be retired very soon, but the archive of the data will remain. So that will give us access still data from 2009. And SkySat also has their unique capabilities, but then Planet, then we have data from PlanetScope. So I really like to point it out. It's also started as one of the companies in California garage, So like we know Apple or I'm forgetting like HP, they also started in a garage. So if they can maintain the track, then there is a great feature of it. So there is a question: is it open source data? I mean, so there are free and open source. So like this is not free. You can get some data for free, but this is a question for bigger. Like we need to have bigger discussions around it. How we can get the data for free as the CG community. So this is just to give you some idea about how the sensor compared to the traditional sensor. So in the left-hand side, you can see you are comparing with digital globe, satellites, and planet. It's probably hard to see because they're so small. And on the right-hand side, there are some. On the right-hand side, there are some sensors that is kept at the plant facility in California, and you can see like they are really different from our how we know the satellite used to be. So this is just to give you some comparison about how the dataset looks like. I should have zoomed it a little more, but you will have access to some of this dataset, so you can explore it more later. So it's basically we have a window where we are comparing between different sensors, like we have MODIS, Landsat, Sentinel, Planet for a same area and on the same time, and you can see how much visual details that we can get from it. The benefit of having the high resolution here. And this is not again capturing the temporal frequency that we will see later. Like I think for the last couple of years, for any part of the world, the planet coverage is somewhere around 1 day to 7 days, but it will definitely like be hampered by cloud cover and other facts. But usually you are granted to have some data set within 7 days. So I got a message about someone couldn't hear. Is it for all of you or just someone? Okay. So next we move to what kind of data we can get from Planet. So basically, there is a web browser. We'll see it just within a few minutes. And if you log into this web browser, if you log into this account, then you'll see that there are like 9 different data products that we have access to, depending on your level of subscriptions. So, and there are a few terminologies that we need to make clear. So basically, if you are familiar with like Earth Engine type interface, then this is slightly different when we are dealing with Planet, how they categorize it. And it is very important to know how, like what they call different products, because that is what you will be using to download or to specify the products that of interest. So all these 9 items that we are seeing here, they are called item types. And any scene, any particular image or any particular scene will be called item. So an item will belong to a particular item type. So a PlanetScope ortho tile will be an like a particular, there could be a particular scene, but it will belong to this item type, and this item type will have some defined set of metadata that can be used for various purposes, like filtering for dates, searching for specific regions, or filtering for cloud covers. So and then if you want to see some so if you want to know more about the details of different item types, you can see like you can get 3-band data, which is basically red, green, blue, great for visual analytics, or deriving something like a green band NDVI. We can have something like the 4-band data, which includes the near infrared, and great for calculating like traditional NDVI as well as EVI based indices. And then this, along with the scene, we can have different type of, you can say different processing levels. So you can have orthotiles, which are basically rectified for the geometrical issues, and also like for sometimes they are converted to a digital number to different other measurements. It could be top of the atmosphere or surface reflectance measurements. And then apart from the PlanetScope, there could also be like RapidEye, SkySat, or Landsat or Sentinel-2. For today, we will mostly concentrate on the PlanetScope Scene 4, which is basically the 4-band scenes that consist of red, green, blue, and near infrared at 3 meters. And when we are talking about any of this particular item, let's again take the example of PlanetScope Scene 4-band. It is also available at various levels. Like you can have the visual image only. We can have different type of analytics products. So these are known as assets. So in Earth Engine, again, I wanted to have this comparison because many of us use Earth Engine, and we will tend to confuse between these two terminologies. So here asset means different level of processing. So whether we want the digital number or top of the atmosphere or surface reflectance. And then also metadata is known as an asset. It is distributed as an XML file. Also, we have this mask layer. Sometimes it is called unusable data mask or usable data mask layer. So they usually give some idea about the cloud cover, and we'll come to it. It's not always works great because of the absence of the thermal band. We need to often come up with our own cloud masking algorithm when working with Planet data. Okay, so next, I will talk about so the biggest challenge. So when we started this project, the biggest challenge we had was how to get the data, because it's if you are familiar with Landsat or Modis or Sentinel, then we know that there is a web browser, there is where we can log in, or we can use some kind of other interfaces to get the data, and there is a defined path and row concept, like the data sets is distributed in a gridded format. But with Planet, if we are looking for the challenge is, if you're looking for any data set that is not for visual purposes, like we want to do some daily analysis, we want to get to the raw data set that is provided, then those data sets are not distributed in any gridded format. Those are like provided in some scenes, and the scenes look very different from what we are used to. So the biggest challenge when we started this project was just to understand these different terminologies. What does it mean by item types, assets, and then how do we find the scenes? And the scenes have very small footprint. So if you're working in a large area, then often the challenge is you will end up with thousands of scenes. So then how do we download those? Now, a couple of years back, that was a big issue. Like we started this project sometime around 2018, and it was a big problem then because the API was not that well developed. It was still under development, and there was no plugins like now available for QGIS or ArcGIS. So next, what we'll do is we'll explore all these three. We will do the first two. Will not cover the API access. I'll point you to some resources, and if you have some questions, I'll be happy to answer about that. But for the downloading, we'll just focus on the first two. So what I need you to do is go to this website, open. So what we need you to do is go to this first link, which says that login and mode equal to sign up, and create an account there. And from there, you can go to this web browser interface. Now, at this point, I must tell you that I will be using some sort of account which we have negotiated with Planet that gives us some privileged access over the data. But with the account you can create now, you will probably get some data set for free for the next 14 days. Now, if you, it's kind of weird. So if you can just go to this website and create an account and just let me know when you are ready, then I'll move to the Explorer interface to show you how it works. And so I have a question here from Michael. Um, so yeah, the question is about the revisit rate. Yeah, so there is no such planned revisit. They usually try to cover the Earth surface every day. And if you want to task some collection, you can also do that. But I have no experience in no, no experience in tasking, like requesting tasking. But there is an option in their API where you can request the tasking. But that is something we have to deal with Planet, like how they do that. But usually the high revisit is kind of sketchy. It's between 1 to 7 days. What I'm seeing now. If your study period is after 2018 or middle of 2017, before that it was much less frequent. So let me know if you can go to the Explorer interface. Um, so I can also start sharing the screen, right?
So Annie, I don't know how you are sharing the screen right now. Oh, there is an option to share your entire desktop. Then we
Yeah.
will see exactly what you are showing.
Um, this one, right?
So yes, okay, yes, it's loading. Great, thanks.
So if you are able to log in, this is what, can you see my screen?
Yes, yes, it works.
Okay, so if you are able to log in, this is how the like interface should look like. So basically, you can search for some locations here, and I have noted down 1 or 2 locations. Let me pull that up. That could be of interest to the community. So the first location that I will show is a place near Sultanpur in Punjab, India, and then if you just enter, so you can search it like this with some name places, and it will just create some arbitrary bounding box around the area of interest. So then there are multiple options to filter this images that is returned. So you can see it says that it's only released in 23 of May. So the next thing I want to do is limit the data analysis between, let's say, October 1 to November 1 in 2019. So let's go to October 1 to November 1. And then what we can also do is we can add more filters. So let's say I'm not interested in SkySat. I'm only interested in 4-band planet satellites, PlanetScope scenes. And then we can also limit by cloud coverage. I generally don't do it because the cloud coverage, the cloud cover layer is not very reliable. If you want the scenes to cover your entire area, you can probably use this one, this option, the area coverage option to limit your limit to the scenes which actually let's say cover more than 50% of your area. So let's go back. And then if we, I hope I could find the scene I was looking for. Yeah, so if we are here and then we can just zoom into probably around, okay, let's do it in this way. Okay, so if you could find this October 23rd image, then you will see that there are scenes. There are some scenes. There are some like smokes coming out. So these are basically the residue burning happening after the paddy cultivation in India. That causes a lot of problem regarding to pollution in just the beginning of the winter season. So you can see like there are many small fields, many small fires that those are burning. So this is in October 23. And what you can do is so now we can explore more. So for October 23, we are looking at like 24 images, like 24 items, and we can inspect one by one. So if we just look at one of them, so it gives you some of the metadata properties that can be used to filter the images that we are interested in. Similarly, we can like just concentrate only one of them. So this will give you some idea about how the footprint looks like. It's like a rectangle, but it's inclined to a certain angle, so it's not definitely gridded in any sense. So that creates a lot of problem when we want to use it for regular remote sensing analysis. So can you please confirm if you are able to see this particular scene? Now, so there are some other options. So here we searched with the name only. The other option could have been we could just draw an area of interest. So we can just take some tools from here and define our own area of interest. There is also an option to upload our own area of interest. So we can have a file, we can have a vector file. It can be in shape or GeoJSON format. Like any of this format that is mentioned here, we can just upload it and use it to find the image that we are interested in. So and also like I'm primarily interested in daily imagery because that allows us to do analysis based on related to phenology. But if we want to do some weekly base map, they're really good for visual products. So if you're interested in weekly base map or monthly base map or quarterly base map, those options are also available. But I really don't find much use of it for the kind of research we would be interested in. I think our primary goal would be to deal with the daily data. Um, so the next place I also wanted to have a look at is I'll type it as a place in Somalia, and our time of interest would be April 22 to May 3, 2009. So I'll just wait for it. It's Belet Wene in Hiran province in Somalia. And then we will change the time of interest to, let's see. And if we zoom into the region, I can draw another region here. So what we are trying to look in here is there was a flood around this time. So we're just trying to use some of the data sets, some of the data captured by Planet to compare the before and after flood situation. We'll not do any quantitative analysis. It's just for creating a visual. Some reason my internet is pretty slow here. It's not. It's not updating the Planet Explorer. So anyway, to do the comparison between 2 days, what we can do is we can take this compare tab, which is just behind the browser, just after the browser. So if you do a compare tab, you can have some imagery which is collected before the event, and then we can add some imagery also which is collected. Let's say I'm not sure. Let's say May 2 after the event, and hopefully it will. Yeah, so for some reason the Planet Explorer is not refreshing the scenes in my browser, but this is how you could use. Probably I can come back later to show you how we can use this compare tool to create some nice visuals for some events. And apart from this Explorer also has some nice options that you can explore. You can save your searches. You can also order, and this labs feature is something like these are some test tools that the Planet team is probably working on, and they want us to use it. So now there are like 3 tools available right now. So that could be used for some specific applications. I never explored this, but feel free to use this. Uh, Apart from that, what we can look into is how can we download some data. I'm not sure if we will have similar level of access. So for example, here I can see, like if you go here, it's very slow. So we can just select some of the scenes, and we can set up an order, like which one we need. We can just say that I'm not going to download this, but I'm just showing you how to create this order. Then you can, like, if you remember, we talked about this item types and asset. So this each individual scene, they are one item, and these are their different assets, whether it is analytic or visual or basic. And they belong to this 4-band PlanetScope item type. So whatever the metadata is content with this particular item type will be available for these images. So now, if you want, you can try to download 1 or 2. Like I will probably try to download one of it. And let's say once you put place order, it will show. So what I understand is these are stored somewhere in a cloud storage, and these assets need to be activated when we request the order. So just now we place the order, so it will take some time to get it activated, and once it is activated, it will download. So this is one way of downloading the image, and it works pretty nicely when you have small number of images and you really want to do something quickly for some analysis, for some visual analysis purpose. But when it comes to like working on a large area, this is probably not the best option that you'd like to use or you'd like to use repeatedly. So what I found out recently is Planet released this wonderful uh, integration. Yeah. So Planet released this integration with QGIS. So if you and also with ArcGIS. Now I don't use ArcGIS that often, so I'll just show you the QGIS results. So like how to use it in QGIS. Oops. I just opened a wrong version of it. So I think the requirement is you should have QGIS 3.6 or later. So I have a QGIS. I'll try with QGIS 10.3. Okay, so to Okay, so to install the API, what we need to do is go to plugins, and we can go to manage and install plugins. And from here, if we search Planet Explorer, so there are two options. We basically want the second one. So I'm not going to install it again because it's already in my system. So you should try the second one, which is called Planet Explorer, not the catalog Planet Labs. And the Planet Explorer is the official version. Now, if you just if you install it, then or let's reinstall it again. If you install it, you can access it from, or does it require? Interesting. Let me see. Let me restart my QGIS again. In the meantime, when we are working in QGIS, what we need is your credentials. So what you need to do is to get your credentials from here, your password and email address, because we'll need that for logging into the Planet account. Now, why don't I see? Yeah, so you should be able to see something like this, a P appearing on your QGIS taskbar. And if you click it, it will ask for Planet, the email address and the password for your account. So I'm going to put the one I have been using. And if the login is successful, you will see something like this. And sometimes it pops up another login window and is asked for the password again. So you can just give the same password that you have for your Planet account. So this is how the interface looks like. So basically what I'm going to do now is I'm going to create some extent and then look for Planet scenes for that extent, so that we can use some of the services that is already available in QGIS. So let's try to load Google Map, and let's go somewhere. Um, let's try to find cloud region. So I'm going to go to California. And somewhere here we can draw a rectangle. So let's say we are going to draw a rectangle around here. And we can also filter the scenes we want and the date ranges. So the date range is fine. Let's say we want something which is very recent. So that could be also a problem with the cloud, but let's try. And then we can hit search. Now, once you hit search, all the image, the available images will be listed, and I have only selected a PlanetScope 4 bands here. So again, you will see different tiles. So first, when you click on it, it will not show you the image itself. It will only show you the footprint. So that will again give you some idea about how the images are being collected by different sensors. So you can see that there is a slight overlap between two scenes, but they are not again in a particular rectangular grid format. So, and if you want to explore more about any of these particular scenes, what you can do is you can go inside and you look for particular scenes. So like here we have 3 of them, and what we can do again is add preview layer to map. Okay, so we got a lot of cloud. So let's change the date range a little bit. 0601. See. And what I have experienced is, like, I didn't use a QGIS interface before, but what I experienced is it's not very smooth. It's much better, definitely much better than the web interface, because you have much control over defining your area of interest, and also the data is coming directly to your QGIS. But sometimes I have difficulties. So another interesting thing is, like, if you keep on adding more searches, it will keep on adding new results. So this is the search from the first one. This is the search from the next one. So let's look at this one, which I believe has much better image quality. So we can add the preview layer. Oops, it's a little bit outside our study area, but we can still go in here. Just confirming if you can. Yeah, so this is much to me, like this is much more attractive to me than the web interface, just because of the GIS capabilities that it's offering. So, and in the web interface also, what I found is sometimes we also saw the rendering is not that great, and we don't have access to the highest resolution data product. But somehow I think the quality in the QGIS, the experience in QGIS is much better. And there is one other thing I wanted to point you out is, like here in the metadata, if you look at it, it says the number of the satellite. So it's basically says satellite 106C, satellite 1061. I don't know how the names are how the names are given, but basically this gives you some idea about which sensors were used to capture this particular scene, a particular area, and the data is coming from 3 different sensors for that particular day. So there is like if you're really interested into very specific measurements, then one of the things that you need to consider is the differences between these sensors, because they have different calibration coefficients. So you have to make sure that you calibrate them with the sensor specific, calibrate the data with sensor specific values. And also sometimes like when you create mosaic, there could be some border effects that also need to be taken care of when if you want to create a seamless one. So even though your data set is fairly small, the data can come from different sensors which uh, cover the data, cover the scene in the same date but in different times. That is also possible. So these are the different factors that we need to consider. And the other issue was the co-registration. Earlier, the co-registration used to be very poor. Like if we had a line feature, then if the data sets were coming from 2 different sensors, we would see that there was a shift because of the co-registration issues. Now it has gone really better. So I don't think, unless your study area is in a very a challenging location, we have to really like think about, we have to really worried about the co-registration issues. So I have explored also it with Google Maps, and that's not, again, not a reference, very good reference, but it it is much better than what it used to be. So that's a really great help, because otherwise we have to come up with new algorithms that would take care of this image-to-image co-registration, but for thousands or hundreds of scenes. Okay, so and now let's say I'm happy with this scenes and we want to order. So basically, like the moment we select, it says the order window is activated. So you can click on here, and once you click on the order window, you will see what you will see that the images that we have selected are available, already checked in. We can again create a order quickly. AMS, and we can say, so here is the question of asset. So we can say, okay, select all asset. What it will do is uh, it will give you the basic data mask, the analytic digital number, the metadata, and the analytic products. Or you can just say, let's say we want only surface reflectance. So you can just want surface reflectance asset, or we can just want add sensor asset. And then what I've seen is if you are selecting add sensor, it is relatively faster than reflectance. I'm not sure if that is a random issue or like whether they are doing the atmospheric correction on the fly. As far as I know, they use this tool called 6SV for the atmospheric correction. So, and then once we are satisfied, we can say place order. And again, the same thing, your order, once you place the order, it will activate the scenes. And when the scenes are activated, it will download in the background. You can see it in the very bottom. When the downloading starts, the progress will appear on the bottom bar of the QGIS, so you can see the progress in percentage. And you can also check the status of the order. Yeah, so this is so what I found is this is a little bit easier and also much better when better QGIS interface, or mostly the ArcGIS interface will have the same experience. It's better than the web browser one, and I would recommend you to explore this more. Once the dataset is downloaded, it will be automatically like added to your layers. And then you can do some visualization or go for some raster manipulation with the data. So this is one of the other ways how you can get access to the planet data. But again, this is very much related to the level of subscriptions you have. So I think we'll have some discussions around it, like how to proceed with the subscription, whether we want it project specific or whether we should go for entire CG level subscription if we can manage a deal with them.
I haven't heard that they deal much.
Like for us, for the university, like we have been getting this data for free, like, and we had some crazy limit. So I think it would be also like with whom we are talking to. That could be another point. So like we have, because of the close proximity, we have been able to invite Planet people to give some talks in the university, and through that we also know many other folks who work there. We have never talked with any salesperson.
But you have to understand their business model. They get a bunch of university students hooked on high-level imagery. Those students go into the workplace, they're asking their employers for it, and all of a sudden they've just cultivated a new set of customers. My impression is from some of the dealings we've had, that they see the CP as a customer, as a lucrative customer. So anyway,
yeah, I don't know.
It's worth having a conversation.
Yeah.
The image is fantastic.
Yeah. And so far we have not used anything, like we are just downloading and exploring, but next we will do some image analysis. Okay, so because what I realized that we are like we will have participants from different parts of the world who will not have great internet, and it is not expected that it is not good. It is not great to expect that everyone will be able to download some planet data. So what I did was I already ingested some amount of planet data in Google Earth Engine. I'll just show you how the pipeline we developed, and we will, and I'll give you temporary access to the assets we have, and we will go through some sample scripts to do some real analysis. So far we only saw how to search and download the images. Now we'll move to how to do some real analysis. Okay, so let's see. I'll briefly talk about the method we followed. So let's see. Can you see my screen? Like if you go to the webinar page, like is it the, yeah, okay, good. Okay, so so the data ingestion pipeline we had for Google Earth Engine was we ordered this Planet data to a local server, and it was done through the Planet API, a command line interface, and then we moved the data from the local storage to Google Cloud Storage using the GS util API, and from Google Cloud Storage to Earth Engine asset as Earth Engine through Earth Engine command line. Now, this local storage could be completely avoided, because now the Planet data is stored in a Google Cloud bucket. So if you have credentials, you can directly move data from the Planet bucket to the Google Cloud Storage account, your Google Cloud Storage account, and then you can ingest it to Earth Engine asset. So there are a few things we need to consider here. First would be the Earth Engine quota that you have. Earth Engine generally allows 250 gigs. So if if the Planet dataset you have it fits within that limit, it's great. You can just use it. Otherwise, you have to find a way to work with it, maybe by subsetting the data at a time. If everything is in cloud storage, you can put a subset of your data as assets so that it fits within 250 GB. And then once the analysis for that subset is done, you can go for the next and so on. So, and there are various advantages of it. What we found is when we were working with, when we downloaded all the scenes, basically what I understood that the data set is like a spatiotemporally rugged. We can have data at uneven temporal interval, as well as the spatial coverages were not always complete. And also the data volume is huge. We are talking about, like, for some study areas, our study area was covering some parts of Tanzania, and the data volume was more than 1 terabyte. And also there was challenges related to, like, cloud cover mostly. Code registration was not that of a big issue, as I mentioned earlier. And to resolve this, we wanted to have some interface which will allow us to quickly check our results, as well as quickly run the processes and could do some analysis. So we decided to ingest our dataset in Earth Engine, and also that allowed us to compare the dataset with easily compare the dataset with other sensors like Sentinel-2. And mosaic creation and any visualization, any rendering was much more faster than it was locally. So this is the study area we were focusing on. So we had 3 study regions in Tanzania: Singida, Dodoma, and Morogoro. And in the right side, we show the total scenes per day, and you can see up to like late 2016, or like February, March 2017, there was not much image, but all of a sudden, from May 2017, we saw a big surge in the image availability. Most likely that is when they launched their 88 satellites at one go. So that could be one of the reasons why the frequency increased, and it has remained like that so far. So we are talking about a very high revisit rate after 2017 March, 2017 May or June. So now I'll show you some quick results. I'm not sure. So we compared four different satellites. We had Planet, we have Sentinel, we have Landsat and MODIS, and what we found, and our objective was to create a model for the maze areas, finding the maze locations. So we adopted a 2-stage classification because we had limited maze training samples. So in a 2-stage classification, in the first round we did a crop and other classes. And once we created that, the crop mask, within the crop mask, we wanted to create maize and other crops. And for that, we had actually around 122 field samples from our data set, and we were lucky that we could find 57 additional data sets from the Tamasa project. And that again talks the value of the open data, because we were able to get Tamasa data quite easily. And once we use the Tamasa data, our accuracy actually improved quite a lot, because the data set quality is really good. So before using the Tamasa data, we were looking at accuracy of the overall accuracy of the order of 70s, in the 70s. But after using Tamasa, it shot up to 86%. But overall, like, we saw that there is a huge difference between how Planet and other satellites were working, and Planet was consistently doing better than the other ones. So what I will do now is give you access to some of this data set that we used. And then we'll do some quick analysis and also compare some data set with Sentinel, Planet data set with Sentinel. So what I want you to do is to go to this link. I assume what I'm assuming is all of you have Artigen account. So if you just go to this link and accept it, you will be able to see some of the scripts I have already written there. And I will just make the Planet resources Planet resource shared for this period, for this workshop. Since I'm not getting a response from, it's kind of tricky to get a response from the remote participants. If you can follow me, then if you can give me some response, that would be very helpful.
Yeah, I just sent you a question.
Okay. Do you want to discuss that now?
Well, I don't know, it depends on the time availability. This is a quick question of the previous slide where you did that comparison. So we said Planet data being much better.
Yeah.
Classifications. I was curious, say something about what kind of data went into that in those analyses, because I'm curious if we can start to define requirements and then we'll spend some sensing perspective to do this well. Is it temporal resolution improvement, spatial resolution improvement, both? If we know that, we can start to try and identify what's the minimum requirement in these environments to do this to an extent.
Yeah, so spatial was definitely a big factor, because what was happening is you can see like our fields were really small. Like we have like 3 boundaries here, so the fields were really small. So in that sense, spatial was a really critical factor. But the temporal also played a huge role, because when we were creating this composites in Google Earth Engine for creating the predictor layers, because Planet had much better revisit rate, like it's almost comparable to MODIS in some cases, we were able to create a good number of indices that were capturing the temporal variability. So that played a really important role. I can share. I don't remember the variable importance from the random forest model on top of my head, but I can share that with you later, like with the participants later. So.
One more question, then if we have time.
Yes.
So, here now in the planets, I can see that
clouds are a big issue.
Yeah.
If you look at Sentinel-1, for example, I've seen some interesting approaches there where, as the cloud cover doesn't really matter, you can still use it for certain detections.
Yeah, so we also use, sorry, I should be very specific. So we used Planet, Sentinel-1, Sentinel-2, Landsat, and MODIS. So the challenge with the Sentinel-1 was it didn't do really well when it came to maize versus other crops. There are some interesting studies also, like that is done by someone from Bhutan. So they are trying to like develop a neural network model, LSTM type model between Sentinel-1 and Sentinel-2. And like if you have cloud, then they are increasing the values. They are developing the imputing the values for Sentinel-2 using that LSTM model. So I think something like that can also be easily incorporated in a framework where you have Planet dataset also. Yeah.
Yeah, on that one, we just heard that I think several consortiums are approaching EU or competing for EU call or having maize and wheat areas in the world.
Okay.
Where the CG has also been asked to provide ground truthing data.
Yeah.
It fits quite well in discussions. And,
yeah.
One of these people is also Beetle.
Okay. Yeah. Yeah, so this is the, so what I have shared now is, let me, so this is a Planet image collection in artificial language. So we can, before we can also see the number of assets that went to this collection. So we had around 6,219 tiles with relatively low cloud coverage. We relied on the metadata provided by Planet, and we eliminated the data that had really high cloud coverages. So that went to the analysis, and then what I have done here is limited the study area to a small region. So it's basically yeah. I just did a time travel. So what we can do is we can quickly look at some visualizations. So if you just run the script, you will be able to do that. So what the first few lines up to line 30 will do is create a visualization for Sentinel and for Planet for the close dates. So so that you can compare. So you can zoom into. And we can also play with. I didn't make any fancy interfaces. Like you can have two windows where you can have a sliding bar to compare these images, but you can also use the layer toolbars to see the differences. And other interesting thing could be you can enable the satellite, and you can compare between Planet and the satellite. Again, there will be differences due to season because the satellite's data might be coming from different year, different time of the year. So, but you can still use it for like some permanent features like land boundaries or roads. But this gives us a nice comparison between the resolution difference between Sentinel and Planet. Now, what we can do next is what I have done here is already supplied you with some classification points. So I have already given you like around 100 points for 4 different classes. So these are basically like we have water, we have crop, we have tree, and we have some open areas that includes basically any non-green except for these 3 classes. Other than these 3 classes, so you can we can quickly run a classification problem. So we can run a classification analysis. So what we can do is, I've also kept some questions here. Like if you want to, if you have time later, we can always go through this step by step. But this is again something related to Google Earth Engine. So I didn't want to invest much time here. Now, if you want to compare this with Landsat or calculate NDVI for both Landsat and Sentinel, and then compare those are the things you can do. So what I'm doing here is adding some new variables. So let's say we are adding two variables. One is NDVI and another is GNDVI, green NDVI. So two different variables. One is with NIR and red, and another with NIR and green, as supplementary to the 4 bands that we already have, and to improve our classification results. I hope it will improve it. And then once we have it, what we are doing is we are creating just a mean composite. So basically, like we are creating a mean from the entire season, which is not always desirable, but we wanted to have a very quick result. So we are just running a mean. And then what we first do is we combine the training samples from water, crop, tree, and open areas, and use those training samples to create to extract pixel values from planet collection or the planet image we just created. So if you do a print of, let's say, this sub PS4, and you can say, I don't want to run overfit. Stop. Should be. Oops. Somewhere which is not closed. So we had 110 images, and then we reduced that to 6 layers throughout for the entire season. Now, what in our study, what we did was we separated this by season. So we had one for early season composite, another for late season composite, and then used that as the prediction layer. But here, just again for quick analysis, I composited everything together. So we can see that we have the 4 bands and 2 indices that we just computed. And if we let the entire script run at this stage, so I'll just quickly take you through the steps. And again, like you will have access to this repo. Most likely, I will change the planet collection a little bit. I will give you direct access to the planet composite, and not the entire collection. So what we are doing here, we are extracting the pixel values from the planet, and then we are defining a random forest classifier with 500 trees. And then we are training the classifier with this 500 trees and the training samples that we have computed, and then we are classifying it. We are also computing the training accuracy. We don't have any validation samples here. We can always add it later, but again, just to show you how the results looks like when we run this kind of analysis with planet data. So it takes some time. Some of the things I learned with Earth Engine over the years is, like, if you are running a large job, or if you expect that your job will fail or give you some out of memory error, don't print it or don't try to add it to the map. So for these cases, what I usually do is I usually export my results to asset. And once the export is done, I visualize it, but I don't think this will fail. This will be a little bit slow, but you can see like it's the tiles started to appear, and the training samples I collected were very quick. I didn't pay much attention, and also the number of layers we could have gone. We could have created much more complex, much more predicted layers here, but just based on what I had, the results visually looks not so bad. So the yellow are the croplands, the reds are the like any open areas, like non-green areas. Blue is water, and green is a tree.
Okay, Annie, I had to interrupt, but we are almost done for the time we allocated for this webinar. So yeah, if there are a few things that you'd like to make as a final remark, that would be great.
Yeah, so that's what I wanted to discuss, and like I will keep the access to the asset for some time, so you can practice. Like anyone who is interested, they can practice with it. And I just wanted to like discuss some of the other I just wanted to like thank my colleagues who were also participating in this work. So like Kate did most of the like Kate took lead on classification work. Camilla was helping me with some of the yield prediction, and then Alex developed a lot of the like a data download pipeline, and then Robert was helping with the classification as well as the prediction. So now from here, I wanted to have some like maybe for later time we can have some discussions around what is the value of the planet data for the CGI research. Like we could like based on the experience I had, it's really good for the monitoring the smallholder farms because of the resolution both in spatial and temporal dimension. And also there is one interesting development. Planet is coming up with more bands. So very soon we'll be seeing 5 band, 8 bands, or 13 bands data. They are calling them super dopes. But then we have challenges with subscriptions. I think we talked about it, like how to overcome with this, and like what are the ways to look forward. So I think we can have discussions around it later. And I will share these scripts with you so that you can share with the participants,
Yes.
or the presentations also.
Yes, please. Yes, but thank you very much, Annie. Yeah, so we got a lot of questions about how we can share and distribute this PowerPoint slide and script and everything. So no, it's really great if you can do that. Okay, so I didn't get any more questions online. So thank you very much, everyone, to join, and also apologies for starting a bit late. Unfortunately, because of other sessions also planned after this webinar, we have to end it here. But yeah, I have your registration information or your registered email addresses. So yeah, we will communicate after this webinar with the PowerPoint slide that Annie presented, and also recording of this session I will share, and then we can have also separate conversation around the subscription and cost and other more practical matters yeah, after this. Okay, thank you very much. Yeah, hope you have great rest of the day, and yeah, we will keep in touch. Okay, thank you, and thanks again, Annie. Yeah, it was great. It was very helpful, and we got a lot of good responses. So yeah, very exciting. Thanks.
Thank you. Thanks.